So here is a little bit of code, and the funny part is this code's easy. Just got to remember what the algorithm is behind it. So in our array-based union in action, it's not just the union too. Remember, we got to do the find first and then the union if the find doesn't find two roots that are exactly the same number. So you know the algorithm pretty well here. We're looking for a redundant item, we're making sure that there's not a duplicate set when returned from, well, both of the finds. So we want to make sure of that. When we showed you the tree representation, showed you the array representation of how this works, so all that we've gone over. The only thing that's interesting though is that in our sample code and stuff like that we have here, we have a union that's going to be first is your child value that you're looking for, and then the root set, I shouldn't say value, but set for both of them. And by the way, be careful with the order here. This is child and this is root after that. There's some books that actually reverse this, or some pages online that reverse this. So be very careful about that. So that would mean some of the code is reversed as well. So again, we know the algorithm, and we're going to merge two roots if it's okay. So I'm actually going to skip this for a moment. So notice in my overall setup, I'm going to do the find first, and I'm going to get two responses of set 1 and set 2 from those two. And we just did that theoretically in the previous video here. So as long as those sets do not equal the same, then I go ahead and do the union. So it's very simplistic. Notice this code's super easy here, gang, and that's the beautiful part about this particular data structure. So that's the overall setup. So again, this is in Java, but C++, just take out the public. And all we're doing is we're setting the root, we're setting the child's value to the root number. Man, I gotta be careful about that. So again, if you don't understand that, go back and visit the previous video that we just had on that. So we have to be very careful about what's going on, because notice root 1 here is the index number for the child, and then root 2 is the actual real root that it's going to be connected to, the highest root in that tree when it's drawn out, and that's why it's going to equal that 2. And again, if you don't remember why that's set up, look at the previous video on how to do that. So here's the overall setup when it comes to a union, and we'll go over an example here in a sec. So in these examples, I did the first two because it does matter the ordering. Remember, the first one is the child. The other one is now who's going to be the master root of that set. So union 6,5 is going to look different than union 5,6, because remember, the first one is the child, the second one is the root. So here's the child, now connecting to the root, and then vice versa for the one up above it. Now again, this is after we've done a find to make sure that they're not already in a set together. So remember that part. I'm not showing that, but just got to remember that part. And then the same thing for this one. If we have a union, the child is 1, I'm going to connect it to 8, so that's why the 1 is now connected to the 8 from here. So that's your overall setup with the union. Easy code, but remember also we still got to do the find as well to make sure that we're okay. So here's everything in action and what you're going to expect if we were to, start our own disjointed set class or something of that nature. So here we're creating the instance. We have two set values that, frankly, we're going to use over and over again because we're just checking to make sure when we do our finds that we don't have a match. Otherwise, we can't merge. So there's our checking our two finds. You'll see that every time we're going to have our finds first before our unions. Now, to be very honest with you here, what I'm not crazy about what you see in front of you is that if statement. Right now we see two finds, but what happens if they happen to return the same root number? There's no real check before they move in to go ahead and do the union. So there's an issue with this code, let's put it that way. So now the author probably did it because well, I wouldn't say but they probably all were separate sets at first. But still, I'd rather have that if statement in between just before you get to the union, just to make sure that they're very, two different sets are coming from those two different finds. So, and then we have our print result here, which is this overall setup here. So I go ahead and drew things out, and then I colored things out, or I should say, drew things out with a tree here. So that's the overall setup for code. So notice it's not really super tricky on this, but it's really, really important for our data structures that we're going to start using a little bit later on.